Angle proofs reference. So everything that we have seen already could still potentially show up in these proofs. Beyond that, we're going to be adding in some things, and we're not actually going to be adding in anything really new. We're going to be looking at stuff that you've already seen before, first of all, and then just using a lot of that stuff with proving things about angles. And as we go through things, I'll point stuff out. If you're having a hard time yesterday, kind of remembering what to do with angles, I'll definitely mention that stuff as we work through today's. But all the properties of equality could potentially be in use here. So addition properties, subtraction properties. So all the algebra stuff that we did on Friday could still be used. Properties of congruence, definitely. Those things could also be used. And then here's some more definitions. And these definitions are very similar to the ones that we saw with segments. For example, definition of congruence in terms of angles. We saw it with segments where you had your two letters without the symbol for segment above it, and they were equal to each other. And then you had the symbol for segment above it with the congruent symbol. That's the same thing here, except it's with angles instead. So the little m, if you remember, means measure of. So the measure of angle A equals the measure of angle B. Then angle A is congruent to angle B. By the way, the two-way arrow here, I'm just going to go back to the notes real quick on Monday. Oh, that's the wrong binder. So go back to the notes real quick on Monday. We saw the definition of congruence had this little term right here, if and only if with segments, which means that the statement works both ways. If they're congruent, they're equal, and if they're equal, they're congruent. That's what the double arrow here means right here. It means this statement can go either way. You can start with equals and go to congruence, or you can start with congruence and go to equals. If you are writing two angles equal to each other, please make sure that you use the little m for measure of. That means the number of degrees for A equals the number of degrees for B. All right. Definition of angle bisector. An angle bisector is almost the same thing in terms of the segment. That would be like a midpoint of a segment because it cuts it in half. An angle bisector cuts an angle in half. And these are definitions, by the way, that we've already seen, which is why we're not writing them down again. These are in your dictionary from Unit 1. Definition of complementary angles. If angles are complementary, then their sum is 90. The little double arrow means that it works the opposite direction as well. So if you're in a proof and you say something is complementary, you can then follow that up by saying that the sum is 90 using the definition of complementary angles. Likewise, if you have a sum equaling 90, you could then make the statement that they are complementary based on the definition of complementary angles, because the double arrow means you can make the statement either way. Same thing with supplementary, except they don't add up to 90, they add up to 180. Definition of perpendicular. Perpendicular lines form right angles. So basically, if something is perpendicular, if two lines or segments are perpendicular, then if there's an angle there, an angle would be a right angle. And if an angle is a right angle, that means it equals 90 degrees. That's our definition of a right angle. So we're going to be using a lot of this kind of step-by-step logical stuff that we saw with segments, but now we're applying it to angles. We had something the other day called the segment addition postulate, where if you take part of a segment and you add another part of a segment, you get the whole segment. Well, we also have the angle addition postulate, where if you add one part of an angle to another part of an angle, ABD up here, BBC down here, you get the whole angle, BDC. This does not mean, I need to be really clear about this right now. This does not mean that those two angles are the same. The only way that these two angles would be the same is if what? And what would make them congruent? What would we have to know about this in order for those to be congruent? Yeah, BD would have to be the angle bisector, which it does not say. We can only say that angles are congruent in here if we have information about the middle line, essentially this ray right here, BD, in this case, being an angle bisector, which this does not say. But we know for sure that those two angles will add up to equal the whole thing because a part plus a part equals a whole. That's the whole idea of a postulate is it's just something that makes sense. We don't have to prove it just because it works and we know that it works. All right. Next one's here. These are theorems. These are the first theorems that we've seen. The first one, we already know. We never wrote it down because we just said what it was, but the vertical angles theorem says that if two angles are vertical, then they are congruent. We already knew that vertical angles were congruent. The reason why we knew that, though, is because of the vertical angles theorem. So if you have two angles that are across from each other on intersecting lines, you can say that those two angles are congruent to one another because of the vertical angles theorem. That would be the reason. There is also the complement theorem. So if two angles form a right angle, then that means that they are complementary. So for example, if you have something like this here, but instead of just being a random angle, ABC might have been a right angle, then you know for sure that the two parts of that angle have to add up to 90. If two angles are part of a right angle, then they have to add up to a right angle. So that means that those two angles would have to be complementary. The supplement theorem. We've actually already talked about this as well. Because we talked about linear pairs. And if two angles form a linear pair, then they are supplementary. We actually use that with our definition of linear pair. But this is the supplement theorem that if you have a linear pair, that means they are supplementary, which means they have to add up to 180. The last two, we have congruent complements theorem. All right, what that means is, and by the way, this works very similarly to the transitive property, but these are not all equal to each other. These are, two of them are equal to each other, congruent to each other, and the other two are complements of that same angle. So for example, it says, if angle A is complementary to angle B and C, I'm sorry, and if A is complementary to B and C is complementary to B, then A is congruent to C. For example, you don't need to draw this or anything like that if you want to. But if we have three angles, A, B, and C, so let's see. So here's A, here's angle A. Here's angle, call that one angle C, and then we'll call this one angle B. So it says that angle A is complementary to angle B. So for example, if A is 30 degrees and B is complementary to it, meaning they add up to 90, what would B have to be? 60, okay. It also says that C is complementary to B as well. Well, if B is 60, complementary to 60 would be what? 30, exactly, it's 30. So if A is complementary to B, and C is also complementary to B, then A and C are the same, which is true. So if you have two separate angles complementary to the same angle, then those two angles are equal to one another. It's like a variation on the transitive property, but it's not transitive because not all of them are the same as each other. Two of them are. And then the same thing works with supplementary as well. If you have two separate angles that are supplementary to the same angle, then those two angles are also equal to each other. So that's all the new stuff that we're looking at here. Not all of it's new either. A lot of it's stuff we've already seen in the dictionary from Unit 1. So we didn't have to write any of that down, so let's turn the page. By the way, this page will be really useful. The first page of the segments proofs and the proofs here will be really useful for actually working through proofs. So what we're going to do first is kind of the same thing we've been doing the last couple of days of notes, and that is stating which thing is being used. So justify each statement. So let's see, angle A. So if angle A, so complementary means that there would have to be two angles that add up to 90. But if angle A is a right angle, then the measure of angle A equals 90 degrees. That's true. Yeah, but why? What theorem, postulate, definition, what are we using to say that? What's that?
Definition of a right angle.
Yeah, I think Serenity, you said that, yeah? I was gonna say.
She said
I
it
said it.
third.
I said it.
You said it second.
She said it.
All right, so this is a definition of a right angle. I'm just gonna say RT for right, and I'm gonna use the symbol for angle. So definition of right angle. If something is a right angle, it's 90 degrees.
Very confident girl.
Which one?
Congruent supplement theorem.
Yeah, the congruent supplements theorem. Good. So if X is supplementary to Y and X is supplementary to Z, then Y is congruent to Z. That would be the congruent supplements theorem that we just saw at the bottom of the page that we just flipped over from. So let's see. We'll call this the congruent supplements. I'm just going to say sup. And then theorem, by the way, theorem is abbreviated THM. Congruent supplements theorem. Advisory is after second period. It is at 10, starts at 10:25.
Vertical angle theorem.
Yeah. Vertical angle theorem. Oh. So if you got two angles that are across from each other, that means that they are congruent, meaning so these angles are vertical, therefore they're congruent. That's the vertical angles theorem.
Definition of a right angle.
Hold up, let's slow it down. You feel free to write them down. I just want to make sure that everybody's following along at a nice pace here. So number 3, once again, those angles are vertical, therefore they're congruent, therefore that is the vertical angles theorem. The next one says that if the measure of angle P and the measure of angle Q equals 90, then they are complementary.
Definition of a right angle.
Let's see. Definition of right angle has to do with only one angle measurement. I see two angles added together here.
Congruent complement.
Definition of complementary angles? Yes. So this would be the definition of complementary angles. Right. And that says right here, complementary angles are complementary if their sum is 90, or if you have two angles whose sum is 90, that means they're complementary, which is exactly what was used here. Two angles whose sum is 90 means they're complementary. All right.
Other one. Yeah.
Definition of a supplement.
Yeah.
I don't see supplementary anywhere in number 5, though.
Wait, which one?
Number 5.
Definition of complement.
We just used that on number 4. It seems like it would be, right? However, here's the thing about definition of complementary. Definition of complementary uses the number 90. And I don't see the number 90 anywhere here. We can definitely make the logical leap from complementary to 90, but it doesn't say 90. It's the complement theorem. Yeah. The complement theorem says if two angles form a right angle, then they are complementary. So we're looking for right angle and then complementary. Two angles form a right angle, they are complementary. That would be the complement theorem. Nice. So the details here are very similar in some of these, right? So if you see the number 90, chances are you're going to be using definition of right angle or definition of complementary angles. If you see something that says complementary and right angles, that's probably going to be the complement theorem. And the more you see these, the more you reference this page, the better you'll get at recognizing it. So that's why this page is going to be really, really important. All right, next one. So if line L is perpendicular, that's what this upside down capital T means. Line L is perpendicular to line M. Then angle 1 is a right angle. I think,
Definition of complement.
wait, what, Vicky, what did you say?
Definition of perpendicular.
It's that one.
That's what I said.
No, you didn't.
So definition of perpendicular. I'm just gonna use the symbol for perpendicular instead of writing out the word. So the definition of perpendicular says that perpendicular lines, and this says we have line L and line M are perpendicular, so those are perpendicular lines. They form right angles, therefore angle 1 is a right angle. So perpendicular lines make a right angle. That's the definition of perpendicular. Definition of supplementary, good for number 7. Yep. Two angles that add up to 180 means that they are supplementary. We see the number 180. That's important here, because the definition of supplementary has the number 180. So this is definition of sup.
Complementary theorem.
What's that?
Complementary theorem.
Is it the complement theorem or is it the congruent complements theorem?
Congruent comp-
Yeah, we got to be careful about the wording there, because especially with the complementary ones. And this is, yeah, a lot of people end up writing this when they mean this. They're super similar in terms of the words, right? Complement theorem versus congruent complements theorem. Make sure that you are specific, because those two things are not the same. So complement theorem, right angle, means that two angles that form a right angle are complementary. That's the complement theorem. Two angles that are complementary to the same angle are congruent to each other. That is the congruent complements theorem. So congruent complements theorem. All right. How about number 9? The supplement theorem, yeah. If angle A and angle B form a linear pair, then angle A and angle B are supplementary. That would be the supplement theorem, because it says that if you have two angles that form a linear pair, then they are supplementary. That would be the supplement theorem. So sup theorem. Number 10, we have two angles that are complementary, therefore they add to 90.
Definition of right angle.
A right angle is only one angle, though. It's not the sum of two. What's that?
Complement theorem.
So the complement theorem doesn't use the number 90.
Angle difference. Definition.
Definition of
Complementary.
complementary angles, yeah. Definition of complementary angles. So definition of complementary angles for that one. If two angles are complementary, that means they add to 90. We actually saw earlier that if two angles add to 90, they're complementary. So it works both ways. We've used definition of complementary angles twice on here. Yeah, Vicky. Complementary angles. What's that? That's an S, yeah. Because angles. 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 What's that? You mean the apostrophe? That's possessive. That's not plural. You don't need an apostrophe there, no. Yeah. Last one is the angle, or not the last one. Number 11 is the angle addition postulate.
I already knew. The moment I saw it.
This is just saying that the left half and the right, oh, I shouldn't say half. That's bad of me. I should not have said half. Sorry. The left side and the right side add up to the whole thing. We don't know it's half, because it doesn't say anything about a bisector. But the left side and the right side add up to the whole thing. That's the angle addition postulate. Last one. Definition of congruent. Nice. Okay. Let's see. What are we out of here today? 9:07. Cool. We still have 33 minutes. So for the last 33 minutes, we're going to do the same thing that we did on Monday.
We have to.
Yeah, I am going to give you another half sheet. So, same thing that we did with segment proofs. Everybody gets a half sheet. I want you working on the first 6 problems. And that's what we got going on today. If you finish the 6 problems in your notes, come check with me. I'm gonna leave this a little bit more up to you now than what we did on Monday, just because you have a better idea now about how proofs work than you did on Monday. So feel free to come up and check with me as you're working through these. We are gonna go over, I am planning on going over all the answers to these 6 before we leave today. I will also give you your assignment today. It will not be due tomorrow, it will be due on Monday, because we're doing today and tomorrow for these notes, but if you want to get a head start on the assignment, I'm gonna get that to you today. So, I'll hand these out, work on these, come up, check your answers, we'll take a look at the answers before we go today.